You might have heard me say or seen in a video people using Pythagoras in 3 dimensions, and you might be thinking, wait a minute, does that work? Well, here's a proof that it does. Here's a vector in 3 dimensions, and the vector A is given by AX, lots of I, and AY, lots of J, and AZ, lots of K. They're the 3 directions, X, Y, Z, or I, J, K. And we want to find the length of the vector A. Well, what we can do first is we can find the length of this line here. This line here using this right angle triangle that's on the floor. So the blue line there has got length AX squared plus AY squared square rooted, because this right angle triangle, that squared plus that squared square rooted is this length here. Right, now this here is a right angle going upwards, so this length here and then up here, this is also a right angle in there, so we can now use that right angle triangle to get an equation for mod A. So the length of A is equal to, well, it's this length squared, which is this squared, which is AX squared plus AY squared, and then we've got this bit here, so we've had that squared, now this squared, that's AZ, plus AZ squared, and then the whole lot, this squared plus this squared square rooted, is equal to the length of A. And then that's the 3 components. That's your X component, Y component, Z component. So for example, 3, 1, minus 2, the length of that vector would indeed by Pythagoras be 3 squared plus 1 squared plus minus 2 squared square rooted. So Pythagoras works in 3 dimensions. Phew!